we have defined power and energy in electrical elements and also looked at power and energy in elements like resistor, capacitor and inductor and found that these components are all passive. Now, we will look at power and energy in independent sources such as the voltage source and current source and see that they can be active. So, this is a voltage source, it maintains a given voltage V equals V naught regardless of the current flowing through it, and as always I use passive sign convention for the voltage and current definitions. Okay. Now, of course, just like for any other element, the power is the product of V and I. It is important to remember that this is the power delivered to the voltage source. Or in other words, absorbed by the voltage source. Okay. This is the power absorbed by the voltage source and the energy absorbed will be just the integral of power, nothing special about it. If you want to find the energy absorbed over a given interval, you integrate the power over that interval. Okay. Now, let me draw the I V characteristics of a voltage source. I will assume that this V naught is positive. We know from earlier discussions that the characteristic is a vertical line at V equals V naught. So, regardless of the current, the voltage is V naught. Now, if you look at the first quadrant, V is positive and I is positive and the voltage source actually absorbs power because the product V I is greater than 0. And if you look at the fourth quadrant, V is of course greater than 0, but I is smaller than 0. That is, I defined in this direction is negative. That means that current will be flowing out of the positive terminal if it is operating in the fourth quadrant. Okay. And in this condition, it delivers power. Okay. So, a voltage source can either absorb power or deliver power. Because there is the possibility of the voltage source delivering power, it is an active element. Okay. Meaning it is not passive. Okay. So, a voltage source can be arranged to absorb power, but it also can be arranged to deliver power. Okay. So, it is not passive when it is operating in the fourth quadrant. This will be clear by looking at a few examples. Okay. Now, let me consider a voltage source of value 5 volts connected to a resistor of value 1 kilo ohm. Okay. Now, we will do this carefully. We do not always have to do it this formally, but you have to be very mindful of the directions of current and voltages that you consider. Okay. So, now what I will do is I will define the voltage across the voltage source to be V 1 and I will use the correct passive sign convention for V 1 and define I 1 this way. So, V 1 is the voltage across the voltage source, I 1 is the current through the voltage source and it is clear that I have chosen passive sign convention for this. And I will do the same for the resistor. Let us say I call this voltage V R and given this polarity of V R, I have to choose the direction of I R to be that way. So, that this follows passive sign convention for the resistor. Okay. So, V 1 and I1 are defined with passive sign convention applied to the voltage source, and similarly VR and IR are defined with the same thing applied to the resistor. So, like I said, we will not always do it this formally, because all of you will recognize that VR equals V1 and IR will be equal to minus I1, and you will also see that the voltage across the resistor is this 5 volts and the current by Ohm's law would be IR is 5 volt divided by 1 kilo ohm is 5 milliamperes. Okay. So, if this were just a circuit analysis problem, you won't define so many variables, but I am trying to make a point here about power dissipated and generated. So, we will proceed formally in the beginning. Okay. So, now what is the power absorbed by the resistor? It is VR times IR, which is 5 milliamps times 5 volts, which is 25 milliwatts. Okay. So, let me also write it here. VR, which is V1, is 5 volts and IR is 5 milliamps, and that is also equal to minus I1. And the power absorbed by the voltage source equals V1 I1 minus 25 milliwatts. Okay. So, this means that the power absorbed by the voltage source is negative. In other words, it is delivering power. Okay. Of course, I could have said this just by looking at having one source and one load and saying that the voltage source delivers the power, but when it comes to multiple elements and given the fact that a voltage source can absorb or deliver power, first proceed with calculations very carefully, defining the voltages and currents correctly. After that, you will be able to do this a lot more easily. Okay. So, in other words, the voltage source delivers 25 milliwatts, which goes into the resistor. Okay. Now, in general, if you have a single voltage source that is applied to a circuit with resistors which are passive, then that voltage source will be delivering power. Okay. If I have a single voltage source and this consists only of resistors, let us say, then this is the only source of power in the circuit and it will be delivering power. On the other hand, if you have multiple independent sources, just to be consistent with this picture, I will show in the middle a circuit consisting of only resistors, and I will show another source on another side. So, let us say this is V1 and this is V2, and we could have even more. Let us say I have V3 and so on. Okay. We could also have current sources, but for now I will consider voltage sources. Okay. Now, we have multiple sources. These sources together will be delivering power to the circuit, but each one of them could be absorbing or delivering power. Okay. So, it is possible that V1 is delivering power and both V2 and V3 are absorbing power. Okay. So, some sources could be absorbing power. Okay. So, this is possible. So, we will take an example of this, very simple extension of the earlier example. So, let me consider an 8 volt source and a 3 volt source with polarity like this, and again a 1 kilo ohm resistor connected to it. Now, I will proceed formally. I will call this V1, and for passive sign convention I have to take I1 going into this terminal. By the way, V1 is the voltage across this voltage source. Okay. This is I1. Now, I will consider the 3 volt source, and I can define the first variable any way I want. So, deliberately I will define it like this, V2. Okay. Note that V2 is opposite in polarity to the voltage source voltage itself, but that does not matter. Once I choose V2, I have to consider I2 like this for passive sign convention, and similarly I will consider VR and IR. Okay. So, V1 I1, V2 I2, VR IR, each of them has been chosen for the 2 voltage sources and the resistor, and consistent with the passive sign convention. Okay. Now, the analysis of this circuit is trivial, and many of you can do it in your head in a matter of seconds. The voltage across this combination, the series combination of voltage sources, is 5 volts, and we have therefore 5 milliamp flowing through the resistor. Okay. So, now we will compute each of these currents, okay, and voltages. So, first of all, V1 equals 8 volts, because it is the same as the voltage of the voltage source, and I1 is defined this way, but in the circuit the 5 milliamp current is flowing in the clockwise direction like that. Okay. So, I1 is minus 5 milliamperes. And their product V1 I1, the power absorbed by the 8 volt voltage source is minus 40 milliwatts, and similarly for the second voltage source V2 defined this way is minus 3 volts, okay, because I have taken V2 to be in opposite in polarity to this one, but no matter, V2 happens to be minus 3 volts. Then I2, which is the current flowing downwards this way, is also minus 5 milliamperes. So, P2 is minus 3 times minus 5, which is plus 15 milliwatts. This is again the power absorbed in the 3 volt source. And finally, the resistor voltage VR is 5 volts and the current IR is 5 milliamperes. So, the power PR is plus 25 milliwatts. Okay. So, it means that this voltage source and the resistor of course are absorbing power. The resistor of course always absorbs power, but the voltage source could either absorb or deliver power. In this particular case, the 3 volt source is absorbing power, whereas the 8 volt source is delivering power. Okay. So, this is an example to show that an independent voltage source could be absorbing power as well. Okay. So, that depends on the operating point of the circuit. Okay. And another thing I want to mention, which we will go into detail perhaps later, if you look at the sum of power absorbed in every element in the circuit, P1 plus P2 plus PR, this is equal to 0. Okay. Now, this is not a coincidence, this is a property of circuits and it can be proven from Kirchhoff's current law and Kirchhoff's voltage law. So, if you take every element of a circuit and calculate the power absorbed by them, that is the products of V and I chosen according to the passive sign convention, then the sum of all those powers will be 0. Okay. There will be some sources delivering power, there will be some other elements absorbing power, but the net will be 0. Okay. So, the summary is that a voltage source can either absorb or deliver power, and if it is operating in the fourth quadrant or the second quadrant, it will be delivering power. which is operating in the first or third quadrant, it will be absorbing power. A resistor whose characteristics are always only in the first and third quadrants will be always be absorbing power. Of course, I am considering positive resistors. Okay. Now, when you have a number of sources, there will be at least one source delivering power and others could be either absorbing or delivering power. And if you have a circuit with a single source, that source will be delivering power. Okay.